Hello, this is Algebra 1, topic 9-2. We're going to talk about more exponential functions. So, we've already touched on these. We're going to continue working on them. This time we're going to go a little bit more in depth. So the first thing is, let's put this in the calculator. I need 4 to the x. Let's go to our table and plot. Well, negative 2 is 0.0625. Negative 1 is 0.25. 0 is 1. 1 is 4. And 2 is 16. Let's go ahead and plot these. Well, 0 is 1. 1 is 4. And 2 is already way off the chart. And if you notice, we keep on getting closer to 0 without actually getting there. And so, I'm going to hug 0. And shoot up even faster than the previous assignment. Now I want you to go ahead and take note of something. If I do 1 times 4, I get 4. 4 times 4 gives me 16. If I go backwards, 1 divided by 4 is 0.25. And if I divide that by 4, I get 0.0625. So what's happening each time is I'm multiplying by 4. So to get 3 would be 16 times 4, which would happen to be 64. So you can see that this is growing extremely fast. We call this exponential growth because of the exponent. Let's go ahead and talk about number 2. Here, we've got pretty much the same thing, but they've got minus 8. So we go to our table, and let's look at what happens. Well, negative 2 is at negative 7.938. Negative 1 is at negative 7.75. 0 is at negative 7. 1 is at negative 4. And 2 is at 8. Let's go ahead and plot this. 0, negative 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, negative 4. 2, 8. And we could use our table and see that this is going closer and closer to negative 8 without ever actually hitting it. As you can see, we just shoot up. Now if we look at these, if we look at this one, and we look at the one previous, I want you to notice that they are the same basic shape. The only difference is that this one has been moved 8 down. So how is it different? It has been moved down by 8, which we can see right here where that comes from. We're going to do what we did before, and then we're going to subtract 8. So it's going to move it down 8. Well, let's see what happens when we do this inside the exponent. So I get my calculator, put into y equals, delete the minus 8. Make sure I'm up top next to that x. I'm going to type in minus 1. So now this looks like this. Go back to my table. At negative 2, we're at 0.01563. At negative 1, we're at 0.0625. At 0, we're at 0.25. At 1, we're at 1, and at 2, we're at 4. So let's plot these. At 1, we're at 1. At 2, we're at 4. Otherwise, we're just hugging 0 like we did before. Now, if you'll notice this graph and the graph up here, it's kind of hard. You really can't see because I'm having to go back and forth on this. But you can more easily see here. Notice I've got the same numbers, except for this one is different. And up here, that was different. So it seems as if I've shifted 1 down on the table, which means that I have actually gone 1 to the right. So it has moved right 1. And so that's what this minus 1 does. The minus 1 moves it to the right 1. Let's take a look at our next example. Here we're going to do two things. We're going to do a plus 2 on the inside and a plus 3 on the outside. So come over here, I change that to be plus 2, then get out of it, plus 3. Go to my table. This time they actually want me to start at negative 4. So at negative 4, we're at 3.0625. At negative 3, we're at 3.25. At negative 2, we're at 4. At negative 1, we're at 7. And at 0, we're at 19. So let's graph what we can. At negative 2, we're at 4. Negative 1, we're at 7. At 0, we are ridiculously high. And then we seem to hug 3 this time. So how has this been moved from the original graph? Well, we can see that it has been moved up, and in fact it has been moved up 3. And we can tell that it has been moved to the left, and it has been moved left by 2. So we can tell that if it's minus inside, it moves right. If it's plus inside, it moves left. If it's minus outside, it's down. If it's plus outside, it is up. And so you should be able to tell how it moves, not from the graph or from the table, but from the very equation itself. Well, let's look at something a little bit different. Let's go ahead and take a look at example number 5. And here, what we've changed is not we've added or subtracted anything. We've said that we don't want this to be positive. We want this to be a negative 4 to the x. Let's go to our table, go back down to negative 2. This time it's negative 0.0625. Negative 0.25, negative 1, negative 4, and negative 16. So when we plot these, 0, negative 1, 1, negative 4, and 2, negative 16, we'll notice that it's just the same as it was earlier, but this time it is upside down. So how is this different? It has been reflected across the x-axis. Okay? It's been reflected across the x-axis. Or you could say flipped vertically. Let's go ahead and take a look at number 6. Well, now we want to do 1/4 raised to the x power. We did one similar to this on the last assignment. This time, negative 2 is 16, and then it is 4, and then 1, and then 0.25, and then 0.0625. And when we graph this, negative 1, 4, 0, 1. Negative 2, we are ridiculously high. So we swoop down and then hug 0. And so if we take a look at this one, and we take a look at our original, you'll notice that they are the same. The only thing that has been flipped left to right. So reflected across y. Or you could say it's been flipped horizontally. And so that is our deeper look into exponential functions, and based on this you should be able to tell what happens to the function, not by the graph, not by the table, but by the function itself. Good luck on your assignment and have a good day.